We're using the we're using the Bosch magnetos. Benix makes them too, but Bosch's are, I think, the better mag for this engine. Uh,
Yeah,
the,
we
the
switched from Bendix to Bosch on the long annual.
Nice,
We
nice,
got
very good.
Bosch.
We're using one mineral oil 120 right now to break it in, and what are we now? About 50 hours, man?
We're getting over that. I think probably the next annual we'll switch back.
Yeah, I was talking to a guy at Tulsa Engines, and they actually use 100 hours now before they change over to the W series oils.
Yeah,
Uh,
that's Tony's target was.
it's kind it's it seemed that if you got five guys, you get five different opinions, but listen, whatever the engine builder says, right? Just do whatever they say. So we're using 80, 87 octane, and if we can get it, so most of the time we're having to use 100 low lead because it is what it is. We've got a lot of ADs on this engine. Uh, uh, we'll talk about some of them on our pre-flight. We can kind of show you some things to look for. Be super careful. I've had actually three. I've had three engine related metal issues on airplanes. Two cylinder heads and one cylinder skirt in the last 20 years. And so we got to really be vigilant as we do our pre-flights to make sure we're not something's not sneaking up on us. Okay, so one of the main ones is checking the spark plug to spark plug area across the top of the cylinders. That's a must. Anytime that cowling comes off, just take a ladder, climb up there, and take a look at each cylinder. On the ground, just do what you can. Just take a look. Make sure you don't see anything with carbon tracking or whatever coming across the top of that. Also, the cylinder heads screw onto the barrels. And so it's a really good idea to look at that interface at the top of the barrel and underneath the cylinder head and see if you can see any carbon tracking going on there. And then the cylinder ears, particularly the exhaust side, are very prone to cracking now as well. And so when you're on the ground, a good idea to just look at each one as you're kind of doing your pre-flight, looking at the front of the engine. I have some cylinder picture here to show you. So there's a nice shiny looking cylinder. So we want to check spark plug to spark plug across the top. Want to check the ears, see what number 10 is. Those crack across there, mostly on the exhaust side, but sometimes intakes too. So here's some dead ones just to show you some ideas of what people are seeing. So here's around a spark plug hole. There's actually three cracks emanating from this spark plug hole. And so you can kind of see where those are going. There's a crack in between these fins going across the top of the head. There's another one in this cylinder here. You can see a crack propagating across the top. There's another one right there. And then here you can see a crack where that lower arrow is, where it's come out. It's going up across the top of the cylinder. And then here's one where the whole thing is cracked off to the side. Here's the top of a barrel between the barrel and the cylinder head that broke. Here's a crack in one of the exhaust ears. And so it's happening. It's happening more than we want to. So here's what we're suggesting that we do. So so where the bottom left arrow is, you can see where that's the bottom of the cylinder head, the top of the barrel. Just give those a look at, and just going across, look at all the cylinders. What you'll see, what you'll see is if something's starting to let go, is you'll see a bunch of black tracking going across the cylinder from side to side. And then look at each spark plug hole as best you can. Look from the top of the plug hole going up toward the top of the cylinder head. And then also look at each of the rocker arm shaft nuts. Make sure those are in place. I had one break. I had a shaft actually break with a nut still on it. It fell off, and then the shaft jacked itself out. And then in the case of mine, the exhaust valve quit operating. And so every time the intake valve opened, that exhaust gas would go out through the intake valve into the supercharger area and would light off the mixture. So the airplane would not run. So I was a dead stick back to me, idle power basically back to an airport. So just try and be really very vigilant on those, and that'll help everybody. So let's see, we talked about that. Visually check the governor for leaks and linkage integrity. Um, We don't have a chiplet on this engine yet. That's a best practice. I would recommend that, Ben, as you guys are planning for your maintenance cycle. And basically it's a metal sensing sensor that goes in one of the drain holes in the front of the motor. We've got the two sumps, and it'll come on and tell you anytime you've got metal in the bottom or anything else. So that'll give you time to get back to an airport if that light comes on. It's a really good thing. Other maintenance items, they suggest we adjust valves every 100 hours, check the
Mhm.
cylinder base nuts every 100 hours. And then there's a magneto bolt safety wire that should be checked at every annual. And then also at annual, the blower to power section nut should be checked as well. You're ready to take the plug off the front of the prop and just check the torque on the prop, make sure it's tight. If the prop ever gets loose, it'll kill the end of the crank. It'll damage those threads, and that's not going to be good. We have a filter on our airplane already, which is a very good thing to have done. And then, as guys are checking the screens at annuals or oil changes, uh, really great idea to just be watching for metal. Could be aluminum, could be chrome, could be steel. So just a really good idea to keep an eye on that. Lots of issues can be found early if you're cognizant of that. Here's a really old article I found about 25 years ago, and it's talking about why cylinder heads break. And so every time a piston goes up the top dead center and that thing fires, it's about a 1200 psi charge that is firing against that piston to send it back down. And so it's just a repetitive forces issue is causing that cylinder pressure. Super important to not overboost the thing because it'll go from 1200 maybe a 13 or 1400 psi. And so that's a big problem, a big issue as to why these things are dying. This is a Pratt and Whitney power chart that I was able to get a bunch of data off of that we'll talk about. And basically, this is talking about takeoff power. So 35 and a half, 36 inches, 65 gallons an hour, 30 and 20, 40 gallons an hour, and then a couple of cruise settings, and then a slowest cruise setting. I've captured those on another slide. This is showing a max overspeed of 2,640 RPM. Like in the backside of a loop, if somebody yanks the power off, the engine can overspeed. So here are the power settings I picked off that slide just to kind of talk about them here. So take off 36, 22, 50 RPM, 65 gallons an hour, rich on the mixture. First power reduction if you're in a noise sensitive area, 27 inches, 1900 RPM. That'll give you about 38 gallons an hour, rich on the mixture control. And so what that does is at 1900 RPM, the prop will not be supersonic anymore in its rotation, and so all you hear is engine noise. So this engine produces a very small amount of noise when the prop is not spinning supersonic. So anything below, like 1975, 1950, the engine will be nice and quiet. So what I advocate is around Cable, Claremont, Riverside. When you're when you're in an area where you've got a lot of high density housing, super good idea to yank the thing back to 27, 1900. When you're at altitude, maybe 2,500 feet or higher, go ahead and push it back up to 30 and 2000. That's fine when you're up high because it won't be as noisy for all the neighbors. See that power setting. A nice cruise setting is 26 inches, 1850, or 25 and 1800 to save some engine miles. And you'll be in the 28, 27 gallon per hour range with a lean mixture at that point. And then the econo cruise setting, if you're trying to go somewhere you really need to get some extra range out of the airplane, 21 and a half inches and 1550 RPM lean will put you back to about 21 gallons an hour. If you're really trying to get somewhere, you need some help on the range, that would be a really good power setting to keep in mind. Okay, formation power settings. What we try and encourage our leads to do is run somewhere around 24 inches and 1850. That allows the formation guys on the wing to be able to have more power for moving around on the wing and so forth. One thing that really important to not do, and that a lot of times they don't talk to guys about this. Very bad thing for engines is to set the RPM at 2,000 RPM and allow the thing to run around at 21, 22 inches. That unloads the pistons. You get a lot of piston slap. You get a lot of stress on that upper ring gland. So if you're on the wing and you're in a good place, run 27 and 1900, or you know, you can run like 26 and 1850, whatever. So it's just trying to be engine conscious. It can really be expensive and bad for the engine if guys aren't keeping the loads up. And so we talk about using an appropriate manifold pressure and RPM. So if you're on a photo mission with a steerman, or you're somewhere where you're flying super slow, run the RPM down, run the manifold pressure, keep the manifold pressure up +8 or so, just to make sure you're keeping the engine loaded. Any questions on that?
No.
Is there too high of a manifold pressure for running around at 1850?
Yeah, you want to keep about 26 inches. You don't want to get over 26, or you'll overboost it. So if you need to go a little, if you need to go a little faster, like push it up to 1900, go to 27, or even 2000 RPM, you can go up to 30 if you need to.
Okay, so but a +8 essentially over the RPM.
Yeah, plus 6 usually is safe. Yeah,
+6. Okay.
yeah. And then if 32 and a half and 2200 is going to be your max, your METO, max continuous power. So yes, sir. Thanks for the question. Okay, fuel system. Okay, so the stock airplane, including the Harvard, has two 55-gallon fuel tanks, 110 gallons total in theory. I recently reset my fuel, or replaced my fuel valve, so I had no fuel in the airplane. I could only get 105 gallons on the airplane 3-point. So, count on 103 gallons useful, something like that. So 110 is probably not going to be the case unless you jack the airplane up and get all the air out of it. So, 102, 103 gallons is more like what you're going to see. So don't cut it too close. We have an engine-driven fuel pump. We have a hand pump. We call it a wobble pump. We have a primer that primes the upper 5 cylinders on the engine. Okay, the fuel selector is left, right, off, and reserve. The fuel selector in the stock airplanes is a little goofy. It's a pretty good system, but it does require some thought the way you're using it. Fuel gauges are on the floor. They do have lights on them. A little hard to see from the back seat, but the front seat guys can see them pretty well. Let's see if we can turn this off. Sorry. All right. Let's see here. So there is a standpipe in the stock airplanes inside the left tank, and I got a slide explaining how that works. Basically, as an overview, if you have the left tank selected, that'll give you the top 35 gallons only. So you have 20 gallons that end up in the reserve side. The reserve in the left side feeds from the bottom of the tank, and you can actually get the whole 55 gallons if you run it selected on reserve. Here's a picture of the standpipe. So basically, what it is the left tank setting draws fuel from this little standpipe you can see here, indicated by that arrow, and that fuel comes out of that port and goes to the left tank setting on the fuel valve. The reserve setting takes all the way to the bottom of the tank and goes out that other little casting there and goes to the reserve tank on the fuel valve. And so that's important to remember, because if a guy is flying around in the left tank and that tank is below 35 gallons remaining, it's going to run out of gas. And so just something to be aware of. And just fortunately, the BT-13 is opposite. So if you ever get flying the BT-13 like Daniel and some of the guys do, they got to always remember that that's going to be opposite.
Hey, Tom, we don't have that, right? The reserve position?
So your plane is just left and right. That's
okay.
correct, right, Ben?
Yeah, that's correct.
Yeah. So anyway, so as you guys fly other T6s, that's something to be aware of.
Okay. Yeah.
Because like Steve, you get in the museum airplane, or when the other guys start flying at Palm Springs, for example, or somewhere else, that's an ankle biter. Yeah. So that's why I'm just kind of bringing it up here. So
yeah, that's good.
Yeah. All right. Let's see. So you're playing.
One question on that: is there ever a reason then to run on the left tank?
Yes, most if you're going on a trip. And so what guys sometimes also do, if both tanks are full, a lot of times they'll take off on the left tank because it's up away from the bottom of the tank. And so you're assuring yourself you don't have sediment if you take off on the left tank setting. And so one strategy guys often do is they'll take off on the airplane. They'll fly a half hour and make sure both tanks will feed. They'll run the left tank down till it goes out. So you've used 35 gallons. They'll go to the right tank, run that one down to the bottom, go back to reserve. You've got 20 gallons left. So if you're on a cross country, that's a really nice way to be able to segregate your fuel consumption. So the first 35, then the second, 55-ish, and then go back to the left tank for the bottom 20. So that would be normally how you would consider using that. Just a couple of quick remarks. Let's see here. The fuel tank gauges run off some metal floats, and sometimes the floats sink. They get leaks in them. They sink. So sometimes after aerobatics, you might get one that hangs up, and it might be all the way empty or all the way full, depending on where the thing goes. So they're pretty prehistoric. The other note is the fuel system is 100% gravity until the fuel gets to the selector valve or to the hand pump. Beyond that, you have 3 to 4 pounds of pressure provided by the fuel pump, or you can also wobble fuel pressure with wobble pump if you had a need to. All right, let's see. And back to the G just for a second, because that's the other derivative you guys might end up flying. The G has 70 gallons left and right. There are 2 additional 15-gallon rubber bladders in each wing. And the G does provide a couple low quantity fuel lights. Our airplanes have, if they're stock, have a low fuel light, but it's actually a fuel pressure light. And so if you're driving along and you have it set on the left tank and you've got gas in the right tank and so forth, you'll get a low fuel light will go on, and you'll actually see your fuel pressure start going to 0. And so it's not actually a quantity light, it's a pressure light. And so you can normally just switch tanks to the right tank or the reserve. It'll normally pick up very nicely. You might have to wobble a few pumps, but normally it'll just pick up and transition very nicely. But the main point of that is it's not fuel quantity on the stock airplanes, it's fuel pressure. Okay, the next other thing just to talk about, since you guys will probably be flying other airplanes, really good idea to know what kind of fuel valve is in the airplane you're flying. Most of the valves have been changed out now, but the stock airplanes actually came with a cork valve, and those are ticking time bombs because it's actually a cork valve that's been varnished or shellacked, and those valves are often starting to fail now. So most airplanes have changed them over to what's called the CJ valve or to the McFarland valve, and so most of those have been changed over now. I'm relatively sure this airplane's been changed over to a CJ valve. So the CJ valves, all this has been taken care of. It's got a nice metallized valve now, but that's really important that if you're flying an airplane with that type of fuel system, only change tanks over an airport because you can't trust them. And that's what they look like. The stock valve is on the left side, the CJ valve is in the right. So I always try and make sure that I know when I'm flying, just to know kind of what I've got. You really can't see it unless you open the inspection panel on the left side of the airplane underneath one of the fairings. Okay, here's a diagram of the fuel system. So we've got the fuel tanks, primer, carburetor, fuel unit, so forth, and the 2 tanks. And there's a fuel valve and a pressure valve there. So that's important to kind of know how that works. The other thing to learn about on the airplanes you're flying is if the airplane has a 1 or a 2-line fuel system. And so what was happening is some of the older restorations had what was called the single-line fuel system. And that works fine until the fuel pump quits turning. So if the thing shears a pin in the drive and the pump stops turning, theoretically the pump could stop in such a way where fuel can't get between the vanes of the pump. And so if you're wobbling away trying to get fuel pressure to the carburetor, it will not work. And so most of these airplanes have been converted to having what's called the 2-line system. And so with the second line in place, you can successfully wobble fuel using the wobble pump to the carburetor. And the other thing on the fuel system is make sure you've got a restrictor in the line that goes to the gauge. I had a fuel gauge bellows fail I did have the little orifice in there, so I still got gas in the rear cockpit, but not as much as if I had an open line. So this slide shows the existence of the second line. So that fuel line with the dash red hatches, that's the line that goes from the wobble pump to the carburetor. And so if the engine driven pump were to stop turning, you'll be able to wobble fuel pressure of the carburetor. That's the whole point of that whole treatise, if you will. Let's see. So theoretically, the wobble pump can supply power to the engine if you've got somebody to wobble the fuel pump. I've heard some guys say they were not successful at higher power. And so at 23 inches and 1700 RPM, you definitely can supply fuel to the carburetor. And so it's somewhat airplane specific. But if you've got a backseater, if you lose the engine driven pump, that's probably a nice thing to have along. That's back to Jonathan's point there. We fuller tank, and a lot of guys do use that left tank when both tanks are full for takeoff. VFR are daytime fuel minimums. You're supposed to land with a half hour of fuel, which would be 15 gallons. That's probably light on a museum airplane, CF airplane, museum airplane. 20 to 30 gallons is better, but that is the legal minimum would be 15 gallons. Normal fuel pressure is 3 to 4 psi, which is really low, but it's fine. If the fuel pressure gets over 5 to 6 pounds, you can actually start blowing fuel past the float, and the airplane can idle really badly. So that's something to look for if you end up with a really badly idling airplane. Is the fuel pressure could be too high. Okay, so best practice: make sure both fuel tanks will feed if you're going somewhere. So get in the air, get some altitude, maybe just switch to right tank for a minute or left, or from reserve or left, whatever you're using. Just make sure that you have two good tanks. Here's a diagram of the fuel system. So you can see both tanks. You can see the selector valve there. You can see the carburetor. Just kind of gives you an idea how all that's laid out in the airplane. You can see the two fuel caps there and so forth. So, any questions on fuel system before we move on to oil? All right, very good. We have a 10.2 gallon oil tank. We have an oil cooler. We have a thermal valve on the oil cooler. Under 34 degrees C, the oil is routed around the exterior of the cooler. It's not going inside the cooler until that valve opens. Some airplanes have oil cooler shutters. I took the shutter doors off of my airplane because I never really see anything cold, and I'm always worried about guys closing the oil cooler shutters, getting the oil super hot before they catch it. I don't remember what's on this airplane. Ben, do you happen to know if the actual doors are on the airplane or not?
No, I don't know.
They're on top of the oil cooler. There's a little rack there.
Yeah, I never took a close look at that.
A lot of guys in Southern California, they either wire them open or take the doors off, so guys can't accidentally get it hot.
Okay.
Yeah, I don't remember seeing them.
Yeah, so I'll look next time I'm over too. If maybe you guys find out, you can let us know. The only other way you can really manage your oil temp on a super hot day is just by your climb. So I was flying the Palm Springs Air Museum's airplane on a 125-degree day, and I was very climb limited by getting to altitude. I was trying to go up to Lake Arrowhead, and so when the oil temp gets over 90 degrees, oil pressure will decrease. And so I'm always trying to keep it like in the mid 80s, so I don't get the oil hot and have the oil pressure go down. So just kind of something I've observed flying out of Palm Springs where it's always super hot. Other element on the oil system is oil pump and temperature and pressure gauges. So on the CF airplane, we were seeing about 70 pounds, and we set the oil pressure up to about 80. If you're looking directly at the gauge, directly on, it probably looks like what 78 psi in the front. See if you're kind of looking down on the gauge, Ben. Does that sound right?
Yeah, I don't know what it was in the back, but yeah, once we tweaked it up, I kept showing like right in the middle of the green, perfect from where I was.
Yeah. So it's a good idea to just kind of have a good visual on where the thing runs when it's normal.
Right.
Airplane gets hot, oil pressure go down a little bit. It makes sense, but just have a good mental image of where that oil pressure runs normally, so when might have some talking to you. So the oil the oil feeds out of the bottom of the tank, and it's under suction from the bottom of the oil tank through the Y valve, which is indicated there with that purple arrow, into the engine. And then the oil comes out of the engine on the back, and it goes to the oil cooler. Stock airplanes used to have a thing called it was called some kind of a pressure valve. They used to worry in cold environments about having um, too much pressure going to the oil cooler. We don't see that in California ever. So, and sometimes those valves stick closed, and it blocks flow. So most guys have taken those out. And Palm Springs, this valve actually stuck closed last summer, and the oil temperature went to like 105, and the pressure went under 40 pounds. And so that was a big old shit, get on the ground in a hurry deal. We thought that we might have had a master rod failure. One of the other things we talk about, it's in the test, if you're flying along and you see the oil pressure go to 40 pounds, usually accompanied by an increase in oil temperature. But if you see the thing go from 75 pounds, whatever, to 40 pounds, that usually means that the oil pressure bypass valve is opened up. And that'll happen if the screen gets full of metal. There's a provision in there where a little bypass will open. It'll feed the engine 40 pounds of oil pressure to get you somewhere on the ground. It'll only run 2 or 3 minutes if it's totally clobbered with metal. And so that's important to keep in mind as well. So if you're flying along, you see the oil pressure go from 75, 80 to 40. That's likely what's happened is the bypass valve was opened up and you've got metal in the screen. Okay, let's see. We'll talk about oil pressures and temperatures on another slide. Now we're on the ignition system. Now on the ignition system, we'll do a power check. A normal power check, you would set the throttle for manifold pressure of the day. So 28 inches, 20 and a half inches, whatever. If the prop is indexed properly, you'd see 2,000 RPM. So plus or minus 50 RPM on the manifold pressure should give you 2,000 RPM. The thing that we're looking for is we're trying to find the index for that particular airplane. We're trying to understand where a good power check is. So on a properly indexed propeller, you'll see 2,000 RPM plus or minus 50 with manifold pressure that they set in the airplane. And so the point is, if it takes more manifold pressure to get to that index, then the airplane is not making sufficient power, not making proper power. So on the CF airplane, I suspect it's off one tooth in the way the blades are indexed to the arms on the propeller, because we only get 25 inches at manifold pressure at 2,000 RPM. So pretty common. Those propellers often come back indexed incorrectly, and it just is what it is. In a perfect world, we take the prop off and move the arms one tooth, but not a deal breaker. The airplane flies fine. It's just you don't get the index as straight away as you normally would. The max mag drop is 100 left and right, and you want a smooth drop. So if you ever get a situation when you select a mag and it doesn't drop at all, then that means you got most likely have a P lead or something's not grounding on the opposite mag. And then it's good practice to do a mag grounding check once a day. So at 600 RPM, just turn the mags both all the way off briefly to make sure everything goes to silent and then turn it back to both. Because we do have to pull this thing through and make sure we don't have anything popping at us. All right, any questions on that? Excellent. Okay, let's go on to the hydraulic system. Okay, so we have a 0.77 gallon tank. We've got about another half gallon of fluid that goes to the flap cylinder, the lines, and the retract cylinders. So total is about 1.2 gallons for the system total. We've got an engine-driven hydraulic pump. And the stock airplanes have a power push control, not this airplane. Same functionality and a valve, but this airplane deals with that with the flap and the gear handle. There's also a filter normally in the back seat. There's a pressure gauge, and we have flap and gear actuators. The brake system is totally separated. It's also hydraulically operated, but it's totally separate from the hydraulic system, meaning if we have zero hydraulic pressure, the brakes will still function. Oh, we also have a manual hand pump. Okay, so the system's going to run about 1,000 pounds plus or minus 50. Uh, the power valve on the stock airplanes is set to 2 minutes. This airplane is also set to a couple of minutes, but we don't have to operate it directly. So when the gear is up, the flaps are up, or gears are down after 45 seconds or so. The fluid is still circulating through the airplane. It's still going from the pump to the tank and back, but it's not under pressure. So the fluid is still flowing. Okay, let's see. We're in reason 5606, red fluid. And just kind of a comment, the flap cylinder is the garbage can of the hydraulic system. So any little seal bits, any water, anything that gets in that system, it's gonna reside in the flap valve. So that's where you'll find all that garbage. So the flap cylinder, flap valve, high propensity getting cancer in there from the moisture, and that's where you're going to get all the crap. So that's a good one to maybe take a look at every couple of years and just make sure you haven't got something going on in there. All right, the hand pump in the cockpit can also move gear and flaps if you need to. Maybe the engine's not running, you can use the hand pump, or maybe you have something going on. As long as you have hydraulic fluid in the system, you'll be able to move flaps with the hand pump. If you have a line break, and all the hydraulic fluid goes overboard, the gear will still free fall. The flaps will not be able to be operated, most likely. You try it and see, but the fluid's gone. Generally, you have a no flap landing. So it adds about 10 miles an hour to your approach speed, and it'll be, another 1,000 foot of ground roll, something like that, most likely. All right, let's see. This picture shows where the power push is on a stock airplane. It's on the end of where that little red arrow is, and it shows you where the hand pump is there as well. And so that's probably all for that one. Okay, a hydraulic pressure gauge is at the end of that little yellow arrow, so it's on that little shelf. So it's between the trim wheels and the followers, which are three. So there's a flap follower and the gear followers there. And that's where the hydraulic pressure gauge is, right there. All right, here's a schematic of the hydraulic system just to kind of show how all that works. So you can see where the fluid goes from the tank it goes to the gear pump, goes through the filter, pressure gauge there, and then it goes out to the respective landing gear cylinders and the flap cylinder there in the middle. So it either blows them down or pulls them up. And here's where everything is in the airplane. So you can see where we've got the gear actuators, flap actuator, and then the tank and the selector valve underneath that. And some check valves in there too to keep everything going the right direction. Any questions on hydraulics?
Nope.
Very good. All right, this is the brake hydraulic system. So a self-contained reservoir. And some airplanes actually draw fluid out of the hydraulic tank. And some airplanes just have the small little reservoir that's actually in the top of the brake cylinder there. And so just a couple thoughts about brakes. Don't drag the brakes when you're taxiing around. These are shoe brakes, and the shoes can get glazed over. And so if they get glazed over all the way, you'll have super good pedal pressure, but they won't be as effective stopping the airplane. And so what I do is anytime I have the wheels off, doing a tire change or annual inspection, I always take some crocus cloth. I just give them a light sanding just to make sure I've got fresh brake media contacting the drum. And I clean the drums too, just to make sure I got really nice brakes. Brakes are also 5606, about 16 ounces for the total system. There is a parking brake in the system. And so the way you set the parking brake is you push both brakes down. 1 o'clock on the panel, there's a little knob. You pull the panel and you release the brakes. That'll set the parking brake. To release the parking brake, you just step on both pedals and you should hear a little click and the brakes will come up to the resting position. Just comment on brake effectiveness. If these brakes are working well, they're perfect for the T-6. They're haze brakes, they're drum brakes. Sometimes guys have put disc brakes on the airplanes, and the red line is one such brake. And in my opinion, you can over brake the airplane, meaning you can put the airplane on its nose if somebody stomps on the brakes. And so that can be bad in a training situation because a guy can do kind of a panic stop and get the tail off the ground. You can hit the nose on the ground. So, and again, they're independent from from the hydraulic system. Here's schematics on the brakes. You can see where the master cylinder is down there underneath the pedals. And so it's all self-contained there. Fill ports there. So if you got the side accessory panels off, there's a little fill point in the firewall below the oil tank. There's a little stem with a little 3/8 inch little nib on it. You just kind of wrench that thing loose, and you just fill the thing up until that little bell is full of fluid. And so you have to just be careful filling it so you don't get fluid. If you overfill it, it'll go behind the firewall and make a big mess on the floor of the airplane on top of the wing. So just be careful in the event you're filling that up with fluid. Okay, tailwheel steering. Here, moving right along here. So this airplane has they call it P51 steering, and so if you push the control stick all the way forward, it pulls on a cable and it pulls a pin out of a clutch mechanism on top of the knuckle, the tailwheel knuckle. So the caution there is when you're turning the airplane without having the pin pulled, think ahead and make sure you push the stick forward when the thing is not loaded. It's possible if you've got the thing, like you say you're turning left and you've got the pin under load, you won't be able to pull that pin out without a huge amount of pressure. If you overload the thing trying to unlock the pin, you can slide the sheathing forward out of these little screw locks, and you can end up in such a manner where you can't unlock the pin without having to take a thing apart and reset the sheath. So be real easy on that lock pin. Make sure you're going nice and straight. Give it some pressure and make sure it's free to go before you really herf on it to pull the pin out. Another thing some guys have done is they'll have the tailwheel lock, they'll have the tail pin in place, and they'll try and turn sharper than the thing can turn based on the amount of rudder and angle that you can get with the pin locked in place, and you can actually slide the tail across the pavement, and you can actually tear the tailwheel tire doing that. So please be careful on that. That can be an expensive mistake. Do lock the controls when you're exiting the airplane. Push the stick all the way forward, and there's a control lock on there, and you can lock the thing forward. Super good habit, because if the ground crew gets on there with a tug or with a tow bot and they try and move the airplane, and the tailwheel pin is not out, it's not unlocked, you can break it. Easy to break with a tug, and it's going to cost you probably $700-800.
Tom,
Yes, sir.
one of the things that Stallion 51 stressed on me was to make sure I push the stick all the way forward, keep it all the way forward, never release pressure, because I had a problem that I would relax my elbow.
Yep.
And that takes the pin and it rubs on the disc there.
Yep.
And then it creates a gouge in it. So make sure you have the stick and keep it all the way forward until you're ready to lock it again.
Yeah, no, great point, Gary. Yeah, good point. Absolutely. I always try and make sure whenever I leave a cockpit on a T-6, I always make sure I have the thing locked. Ground guys want to be helpful. Sometimes they're not thinking. Maybe it's a new guy, but I always review that with the ground guys. Hey, make sure you rattle the aileron. Just make sure the controls are locked, which would indicate that the kind of a byproduct is the pin is out. So kind of the Achilles heel on moving that airplane around, and it happens, but we just got to make sure we minimize it happening. Okay, any questions on that?
No.
All right, moving along. Okay, let's go on to the electrical system. Okay, so the T6 has most of them have a 24/28 volt system. They're 50 amps. Some T6s are still using generators and reverse current relays and carbon pile regulators. This airplane has been changed over to a JASCO alternator. So it's got a JASCO 50 amp alternator with a transistorized regulator in it. They work super good. The main thing, you got to keep cooling air on them. And I've got a picture of ours. We've got nice cooling air blasting on that thing, but a JASCO will die in about 30 hours if you don't keep it nice and cool. The cut in, cut out RPM is somewhere around 1400 RPM. You can normally hear it in your radio. You can hear when it clicks in. Let's see, whenever we use external power, like off a start car, battery and generators have both those off. and get the thing started, get it going, yank the plug, then turn them on so you can prevent any voltage shocks or anything going to it. If the alternator dies, there's a voltmeter in the airplane on the right hand side. If you see anything under 28.3 volts, if it goes down to 24 volts, that means your alternator has gone offline for whatever reason. So in that case, I would turn the battery off and just conserve the battery for radio needs, in case you need to get somewhere at a tower to be able to talk to the tower, whatever. And then there's a test question basically saying if the battery and alternator switches aren't on and alternator is not working, the battery won't charge. So that's just one of the test questions. So here's a schematic of the charge system and the battery buses in the airplane. So there are actually two buses in the airplane. There's what they call the battery bus, and the battery main bus powers like the starter and the radio compass. No inverter any longer. And then they call the console bus are the items that are maybe secondary. So like old Evolution, we had a cockpit lighting, fuel gauge lights, all that kind of stuff. So that's the way the thing is wired there. All right, just kind of a hot setup for Ben. I'm not sure what's in this airplane. I think there's just like a Concorde battery in this airplane right now.
Yeah.
There is a good setup that guys have been using with great success that's super inexpensive. So the first time you build it, you'll have to buy the stainless steel jet case. But there's a 337 on it. You can use the Odyssey batteries that are $130, $140 a piece. They last 6 or 7 years. And I think the Gill batteries they're well over $1,000 now. So that's something that you can easily do if you plan ahead a little bit next time you need a battery.
They have an STC out for the Odyssey batteries, or is it?
There is. We got the 337's field approval. I've got a copy of it. You're welcome to have a copy of it.
All right.
Okay, let's move on to the propeller. Okay, so we've got a 12D40 on here. It's a counterweighted propeller, a constant speed, obviously. The full length blades are 60 inches. They cut off 12 inches and round them or square them. That's where you get the 6101-12 nomenclature. 117 and 7/8 inches diameter. Low pitch is 12 degrees. High pitch is 26 degrees. So the counterweights are balancing against the high pressure dome oil from the governor. And so the flyweights inside the governor establish the RPM that we've got set in the governor. One of the main things here as pilots we need to be thinking about is if you have a governor pump failure, the oil pressure goes away and the counterweights are going to drive the propeller to coarse pitch low RPM. And so what you'll see flying along if that happens is maybe you're at 26, 25 and 1800 or whatever. The governor goes away. You're going to see the RPM falling off down to like 1450, 1500 RPM. And the manifold pressure is going to try and go to like 35. It's going to just start increasing. So it's analogous to having a car in fifth gear and you're trying to get away from a stoplight. So you're going to get massive cylinder pressure, very low RPM. And so the first thing to do is get the throttle out of it so you're not going to overboost the engine. Try messing with the prop control, see if you can get it to come back by kind of exercising it. If you can't, you're going to be in a pretty slow descent to a landing somewhere. So when it happened to me, I was actually coming in to an airport. I was already planning on landing, so I was just descending. And I got this big kind of rattle. RPM started running down to 1500 RPM or so. As I said, the RPM came way up. So I was in a really good place, but can happen in a bad place. So just kind of be aware of that happening. Other thing that infrequently happens is the counterweight bolts can fail. And if that happens, you get one blade will just kind of go loose. You have one blade tied to the hub and one of them won't be. You get a massive amount of vibration and you're gonna have to land also with that happening. So a lot of guys have had their prop reworked to a higher diameter bolt. I'm trying to if I could talk. And so guys that fly a lot of formation have put in there's a mod you can have done that changes the barrel, that changes the bolt to have a larger bolt on your prop. So that's something guys are doing as well. When we shut the airplane down and we pull the prop control back, we push the RPM up to 1200 or so. Some books say 1400. That's a lot of RPM. So I suggest we go to 1200 RPM. As the RPM winds down, you can hear the thing coming back. And then as the airplane starts knocking, when the propeller gets back to its full decrease position, just pull the throttle back to like 750, 800 RPM or so, and then pull the mixture back. You shut off the carburetor, pull the mixture back, and it'll shut down. And the prop will cover. And what happens there is a hub covers up the dome, or the dome covers up the cylinder right there, and so it puts it in a nice position for restarting the engine the next time it starts, and it protects the cylinder from getting crap and dirt and stuff on it if the airplane's been parked outside. Okay, runaway prop. So we alluded a little bit to that before. So if you guys on the back of a loop and a person reduces manifold pressure, you can get a prop RPM to go up to 2,600 RPM or so. Also, if the thing runs out of gas and you try and restart it, it's a good idea to pull the throttle back too, because sometimes that also can cause an overspeed condition. I have two books. One book says 2,640 is max overspeed, and one book says 2,800. So, like a lot of the T-6 stuff, newer books have different information than the older books. The point is, don't exceed 30 seconds, otherwise you're going to be in no man's land for having an engine that spun too fast, too long. Okay, let's see. So if that happens, you want to nose the airplane up, try and load the prop, pull the throttle back, pull the prop control back, and try and get the prop to govern again. So that's pretty much all you can do. Here's a kind of a schematic showing the prop and kind of what's happening as the prop operates. So for low pitch, you're getting oil combating the counterweights to be able to set the RPM that you want. And then high pitch down here, you have oil going out of the propeller. And then in a governor failure, that check could be up above. So in a governor failure, you're going to coarse pitch low RPM. So anyway, any questions on that?
No.
Excellent. Hey, we're moving right along, guys. Okay, next one is the carb air. So we have filtered air and we have carb heat, carb air. And so on the carb temp gauge, you always want to keep the carb temp higher than 3 degrees centigrade. And on a colder day with a lot of low clouds and stuff, the airplane will get close to 2 or 3 degrees centigrade. And that's where you can get carb ice building up. So I always run a little carb heat. So on the left side of the airplane, there's a little lever. You put your little ball, you push it down, pull it back a couple slots, and then release it. The little knob comes back up, and it'll stay in that situation. So you want 5-6 degrees centigrade, something like that. If you have it open too far, you can get it as high as 15 degrees C. That's too hot. So you would not want to run the carb heat in such a manner you have the carb air temp getting too hot. Here's kind of a picture of it. So the upper one is cold air. So the air is going to come in through the inlet on the left side of the cowling. It's going to go down through the mixing chamber and go up in the carburetor. If you have carb heat selected, the carburetor air is going to be drawn from inside the engine cowling area. It'll mix it up and go in the carburetor from there. And there's a little diagram of the knob there showing you how that thing works. Okay, let's move on to flaps, our next system here. So flaps on our T-6 are 3-section flaps. They're hydraulically operated. There is a cross rod that goes away from the flap cylinder. It goes out to the right wing panel, and conversely on the left wing panel. There are little rods that connect the flaps to the drive rod. If the airplane ever has flaps deployed at too high a speed, those little link rods will get bent. And so you'll be able to tell that there's a problem there. And the flaps will probably be super hard to pump up and down because those little articulating rods are bent. We have 45 degrees deflection for flaps. Our flap deployment speed is 125 miles an hour. The flap control is interesting. It's kind of like rubbing your head and scratching your belly. So there's a 3-position flap control. It's got, the middle is lock. You've got down and you've got up. And so the way the thing works is you grab the flap control, you want to put flaps down, it takes about 1 second aft, and the flaps will move about 10 degrees, you go back to lock. If you overshoot locked going to flaps up, all the flaps will go up. So it's just, you just have to get used to operating them. So about 10 degrees a second of deployment. You want to go them all the way down, just put all the way down. They'll go down 4 seconds or so, they'll go down to 40, 45 degrees. We normally use a progressive flap deployment in the airplane, where being the numbers, we'll put down 10 flaps when we're like 120 going on downwind. And we'll add 10 degrees more as we get into base. And then we'll keep the last flaps based on wind, based on if the field is made or not. If the field is made and you don't have a lot of wind, it's best to always use full flaps so you land at a slower speed and save the tires. So your first few times you'll be going over, you'll be going back. So it'll be a little bit of a trick getting it so you understand it, but no big deal. We have indicators on the little flat area where the hydraulic gauge was we looked at. There's a follower for the flaps, and there's a follower for each left and right gear. So that's the way you can kind of see what's in transition and where those devices are at the time you're doing it.
Hey, Tom, have you ever seen the max flap speed is 115 miles an hour?
I haven't.
Hmm.
It could just depend on the book, Steve. It's like,
Yeah.
What I tend to do is I tend to use the G book when we're working with new guys, because it's a lot more verbose. There's a lot more text on what's going on with controls, better diagrams than like maybe a D book or a C book. So, okay, let's move on to the landing gear. So obviously we have a nice retractable landing gear. The gear in this airplane works really well. If it's set up good, the thing is very reliable, works really well. So we have mechanical locks holding the gear up and holding it down. Let's see, we have a landing gear handle that's going to control the hydraulics as well as the gear locks. And so, gear in this airplane, gear down activates hydraulics as well as releases the up locks, and the gear will come down nicely. Test question: we're using 2 7/8 inches on the main gear for our oleo inflation. The gear cannot be raised and lowered from the back seat. I've been in a couple airplanes where the back seater can put the gear down, but cannot raise the gear unless the detents are all messed up. So just normally speaking, the front seater is going to have to run the gear up and down. Okay, we've got a 3-position gear handle. So we have up, we have down, and we have emergency extend. And so normally the gear is going to be, say, in the up position in flight, and there's a detent in there. And the detent holds the front handle, locks it up nicely. The back handle just follows it. When we want to put the gear down in this airplane, see where there's a pivot here in this picture. So some gear handles pull away and then can go down or up. This one pivots and goes to the right. So you actually move it to the right, and that unlocks the detent. So you can see that brown colored piece of metal between the two red sections there. That's actually the lock. That's the lock that goes in the detent. The detent is on a steel plate, and it has a detent in the upper position, a detent in the lock position, and then there's an over center emergency extend position below the down setting. All right. So next thing on the gear that's important is the gear lights don't assure that you have a locked gear. You could have 2 green lights and the gear might not be locked. The followers show the gear travel or gear movement. They do not show gear locked either. The only way you can know if the gear is locked is if you look out the window and look in the little bitty gear pin windows. You've got to look outside, look down at about a 60-degree angle to see them. And you can see the steel lock pin blocking a red steel block that's on top of the gear casting. That's the only way you can guarantee yourself that the airplane is locked. The other caution is when you go to put the gear down, be sure you stop at gear down position. You can go over center, and you can actually lock the gear out of down before it has a chance to get there. And so that's something that we don't want to do, obviously. And the max gear extension is 140 miles an hour. Let's see, a couple other questions here. The main gear tire pressure is 32 pounds. Tail wheel is 48 pounds. The tail strut extension is just so that the boot is going to be parallel to the ground. A lot of guys overextend the struts, the tail strut. If you get the strut extended too much, it won't act as a shock absorber. It'll be too firm. It'll start banging rivets. It'll mess up the tail wheel steering geometry. So you want it lower rather than higher, so the thing acts as a shock absorber, and the thing rides nicer. Everything is nicer with that, not pumped up to the heavens. Okay, so I have a picture coming up. I'll show you a little bit more of this, but the gear lock pins are driven forward by a spring on each gear pin. If the spring breaks, you will definitely need the emergency extend lever to go all the way forward, all the way down to push the pin forward and lock it. So that's why it's there. So here's a picture kind of showing that. So in section 1, you can see where the pin is forward, and there is no the gear hasn't gone by it yet. So that's got the pin in the extended position, but no gear. The middle picture shows that the gear is down. You can see where the red box is. So that little red box is on the top of the gear casting, but for some reason, the gear downlock pin hasn't gone forward to lock it down. So it could be that the spring is broken, probably what it is. You can see in the picture, the spring is unwound right there. And then in the rightmost picture, you can see the red painted steel piece on top of the gear it's in the catch, and the lock pin has locked it down. So that's the only way that you can assure you've got a down gear. Now, don't rely on the followers, don't rely on the lights. You've always got to make your circle all the way around. Another way you can verify that the gear has made its travel is you can pull the throttle back to idle and you will not get a horn sound. So that's another way you can also just verify that the thing is electrically down anyway. Okay, so here's a picture of one of the gear doors in the airplane. So you can see the downlock pin. You can see that it's locked against the top of the red casting inside the fingers right there. Happens to be that the oleo is right. The oleo inflate port is right there as well with the yellow cap on it. And then there's a threaded bore lift shown right there, which is where you put the lifting rings to lift the airplane off the ground. If you were to have a gear problem, you had the airplane on its belly. And I suggest if you don't have a set of those, there should be a set in the baggage compartment at all times. If the airplane goes somewhere and it slides in, especially at a towered airport, they're going to want that airplane out of the way. And so they'll want to be in a big hurry to either sling it or forklift it off the runway. And so that can really get some damage going. So if you have rings on there, you can thread them in there. And then it's just a matter of lifting the thing up with some straps or some chains and get the airplane off its belly and put the gear down. Tail struts here. It's inside one of the little access doors underneath the horizontal. And then here's a diagram showing how you would lower the gear if you had a complete hydraulic failure. And so you slow the thing down to gear speed at 125. Throw the gear handle to down position. The gear will leave the wells and fall. And you yaw the airplane if necessary to lock it, but usually it just falls down and locks. Verify the landing gear followers have gone down. Check the window to make sure it's locked in place. And if you want to, you can always retard the throttle away to stop, and you should get your gear horn at about 15 inches or so. Ours isn't working quite right yet, but I'm sure the guys will get it sorted out. Okay, on the flying side of this thing, when we're doing our training, it's really a nice thing to be able to, as guys put the gear down, it's really nice to be able to get to the gear speed, 140, whatever, gear handle, and have the guy in the front say, gear down, followers, I have 2 green lights. I've got 2 pins that I can see outside on the wing, gear's locked. And then you could also retard the throttle and verify there's no horn. For gear up, positive rate of climb, gear up, 2 lights go out, the followers go up, and horn wouldn't honk if you had checked it. You can also check the hand pump. If the gear is up in the well, the hand pump will be super tight and won't be able to move it. That's another way that you can tell. Let's see, here's a little slide showing, just kind of reminding where the lifting points can be. And here's a picture of these lifting rings. I got mine on eBay for like $100, and so I've got them in the trunk of my airplane. Ben, do you know if you guys have any in your airplane or not?
No, we don't. I mean, no, I would say not. I'd have to look through the tool bag, but I doubt it.
Yeah, it'd be a really good idea to buy it, except just throw them in.
What are they called? Are they a standard size thread or?
Yeah, yeah, those are North American parts actually.
Okay.
Yeah, I got mine on eBay. I can help you find them if you. It's super good idea to have them because you just don't want to get your airplane more damaged than it might have already been. All right, let's move on to some of the gauges here, just to kind of talk about those real quick. So on the 3-in-1, it just kind of indicates the oil temp, fuel pressure, and oil temperature. So you can see the pressure wants to be between like 70 and 90 on the oil pressure, fuel pressure 3 to 4 psi, and the oil temp 60 to 80. 95 is going to be your red line on your oil temperature. So airspeed, it says 240. FAA now has the airplane placarded at 226 miles an hour on VNE. Accelerometer minus 2.33 and plus 5.67. Hydraulic pressure, 900 to 1150 or something like that. And then the suction would be 375 to 425. Okay, any questions on those? Perfect. Okay, a couple more to be thinking about. One thing on the T6s that is important before a guy does a run up, always make sure you've got 150 degrees C on the cylinder head temp. Even on a quick shutdown, like Ben and I shut down to have lunch the other day when we were flying. We came out and taxied out. We were like, what, maybe 120, something like that. So even on a hot day, it cooled off quite a bit. So run a little bit of moderate power, like 1,200, 1,300 RPM. Make sure the cylinder head temp gets up to 150. That's important to make sure all the cylinders are nice and warm. Carb mix
down to like 150 just on the taxi backs.
Yeah. And so and you'll see 220, 230, something like that flying around, 232, something like that. So 230 to 250 is a nice temperature to be on the thing when you're flying. Okay, carb mix. There's a carb mix at 3 degrees. 3 to 15 degrees is a nice range to run on there. Manifold pressure green is going to be 26 to 32 and a half, something like that. And then the tax is going to be 1,600 to 2,200, something like that. It's going to be what you're normally going to see. Okay, some prohibitive maneuvers. So snap rolls over 130. Why would snap a strut anyway? I would probably, Steve Rose would probably get mad if we were snapping it anyway. Slow rolls over 190. Inverted spins, outside loops, no. Spins and stalls over gross weight, no. Anyway, flaps, no full flaps over 100 1/4, no gear over 145. Okay, some operating items just to talk about. I'm kind of knocking out some test questions here. So our noise abatement climb is 27 to 1900. When the airplane's descending somewhere, when you're coming into the airport environment, no less than 22 inches. That'll help us keep our cylinder head temp over 150. If you pull it back to 18 inches or less, somewhere less than 2200, the cylinder head temp can get down under 150, and we don't want to be warping cylinders or anything like that. So we want to keep the cylinder head temp up. Best glide clean is 100 miles an hour. That's about 9.6, a glide ratio 9.6 or so. Best glide 75, prop back. It's about 6 miles, something like that per 1,000. And then before solo flight, we want to secure the back seat, belts, harnesses, headsets, whatever. We also want to take the stick out and make sure that's either in the baggage compartment, it's in a little socket in the back seat. Minimum runway length, for a newer T6 guy, 3,000 feet. After you've done it for a little bit, 2,500 is fine, but I wouldn't get too aggressive with it until you have a bunch of hours on it, just so you're not scaring yourself or you have breaks or whatever. All right, operating items. We have a mnemonic that we like to use when we're training: and glide gas, gear, fuel, mags prop, canopy harness, flaps, trim. So we're just trying to cover all the items, just kind of memory items as we move through it. Okay, limitations. So the Harvard 2 T6 Ds and Cs at 5,300 pound gross weight. G's at 5,625 pounds. So if you had to carry some extra baggage, I don't know, you got to be careful a bit. If you're going somewhere and using up a bunch of gas to get you back in the 5,300 pound range, you'd probably be not a big deal. 5.67 G's positive, 2.33 G's negative. Rolling pullouts, make sure you don't use any more than two-thirds of the max G. So somewhere around 3 G's on a rolling pullout would be plenty. Better in a situation where if you're going down a low pass, pitch it and stop and then roll. That's a good, safe way to do it. These airplanes are 80 years old, so don't want to get too carried away. So here's your classic performance diagram here. So this shows you if you go up the dotted line to the limit load factor, your VA maneuvering speed is about 175 miles an hour at 5,300 pounds. The airplane's going to stall at the square root of the G, just something to keep in mind. And then the FAA red line at 226 miles an hour. Okay, weight and balance on this airplane. We're 3,940 pounds empty airplane. So drain, I guess unattainable fuel and oil is going to be 3,940. With 2 people in full gas, you're right at 5,000 pounds. Maybe some more baggage, you could be like 5,100 pounds or something like that. Down on the bottom, it's a little hard to see, but the most forward CG is going to be with pilot only at 200 pounds and 93 pounds of gas and 185 pounds of baggage. And then the most aft CG is going to be 200 pounders, full fuel, and 90 pounds of baggage. So airplane is a little sensitive when you're low on gas on one person. So if you're going to be doing aerobatics, just give it a check and make sure you're in a good CG range. You get good nose drop when you're up doing stuff by yourself. Okay, stall speed diagram. At 5,000 pounds, power off somewhere around 71 miles an hour with the thing windmilling clean, and somewhere around 60 miles an hour stall, straight and level with the thing windmilling. So we'll spend a lot of time doing that in the air to kind of show how all that feels. There's some items that affecting stall speeds and stall characteristics. So interesting stuff there. Okay, here's a diagram that shows how much altitude can be lost in a 4G pull, and so it's about 1,000 feet, something like that. So the Mustangs and some of the faster airplanes that can really get you in the corner. Not quite so much in the T-6, but basically what that says is if you're at say 4,000 feet and you initiate a pull out from a 4G maneuver, you've got to have the air at 4Gs already in the pull. You'll lose at least 1,000 feet in recovery. Okay, here's an approach and landing diagram from the G model book. So what these guys are doing for training is they're leaving the prop set at 2,000 RPM. So they're coming into the airport environment, coming in on a 45. So you're coming in maybe 130 miles an hour, establish on downwind. They're pulling the throttle back to maybe 22 inches, gear down. I've been teaching guys when they add the gear, add a little bit of throttle, simulating to adding a little bit of throttle to make up for the increased drag. Base at 110 miles an hour, flaps 20, and then start setting up for your final approach. 90 miles an hour, flaps full if you don't have any wind to worry about, and land the airplane, either wheel land or 3-point it. Go around in the airplane when you've got the airplane already set at 2,000 RPM is nice. I mark the prop quadrant in the back so I know where 2,000 RPM is, so I can set that for you. The point is on a go around, 30 inches and 2,000 RPM is plenty. You don't need to be running 36 inches and 2250 on a go around. It's just too much power, too much engine. So don't slip the airplane under 90 miles an hour, under 200 feet. And then on the go around, add the trim, positive rate of climb, 200 feet, get the gear up. Then you can start bringing the flaps up, at that point from a couple hundred feet. All right. Let's see. Here's a slide showing the glide distance at 100 miles an hour. You can glide about 9 statute miles for 5,000 feet of altitude. That airplane is a little bit heavy. That's a G model airplane there where that's from. So roughly 9 miles for every 5,000 feet of altitude. Here's a diagram that we'll talk about when we're doing training. We got a high key, alternate key, and a low key. And kind of the point here is it gives you some references as far as where you can initiate your, kind of your memorized approach patterns for engine out. And so, roughly 100 miles an hour, so 3,000 feet over your landing point, alternate key at 2,000, another key at 1,500. And one of the main points here is aim about a third of the way down the runway, because you'll always come up short because we don't get to practice this every day. So you can always S turn when you need to land a little bit, shorter if you need to. All right. Okay.
What kind of power setting do we use to practice the SFO?
We're using 1850 and about 15 inches.
Thanks.
Yep. Okay. We're just kind of talking some op stuff right now. So I really try and get guys to program ourselves so if we take the runway, have a mindset, today's the day it's going to quit. We're trying to be locked and loaded for a situation where we have an engine failure on takeoff, trying to save 2-3 seconds, whatever, so we can kind of be spun up in the airplane and know what we're going to do. So we always want to make sure we have a plan. So if we've taken off and things sputters and quits, nose over, change tanks, see if that might help. Fly the airplane, 30 degrees or so left and right. Just kind of fly the airplane to get when you get there. If you're higher and you have the ability to turn back, you want to be at least 1,200 AGL to be able to start thinking about turning back. Here's a forced engine diagram here showing 100-mile-an-hour best glide. At that point, wheels are up, prop is full decrease, and you're gonna fly the airplane around. And then when the gear and the flaps are down, you're gonna transition to 75 miles an hour indicated airspeed. No slipping below 90. Land as close into the wind as you can. And so that's a nice diagram showing that. Here's some data showing you in a glide situation what the glide ratios are. So 100 miles an hour, gear and flaps up, prop decrease 9.6 to 1. And then gear down, flaps down, prop decrease 75 miles an hour, about 6 to 1. Okay, bailing out. Okay, so if we're in a situation we had to bail out of the airplane due to a fire or collision, loss of control service, whatever it is, you want to bail out on the outside of a spin if it happens to be spinning, and canopy open, harnesses release, unrelease unplug your helmet or headset, and you're going to dive toward the trailing edge of the wing. Get clear. Parachutes probably are good at 2,000 feet if you can get out and get a full canopy. So early decision is good. Early decision is better. All right, here's some data here. I just pulled off some of the charts. So 60 degrees Fahrenheit, 1,800 feet altitude, 800 feet, 1,000 feet of elevation, about 950 feet ground roll. At 95, it goes to 1,050. So you picked up only about 100 feet. It's not bad. Let's see. This is landing here. So roughly 5,500 feet. We need about 800 feet to land, and about about roughly 1,500 feet to clear a 50-foot obstacle. So the airplane does a nice job there. Okay, some things to think about. So we're just kind of knocking out some test questions here as well. So, cold engine off, so want to make sure we allow the engine an opportunity to warm up. So when we start the airplane up, once we have 20 degrees centigrade, we can start the taxi with low power. And then we want to make sure we have good cylinder head temp and good oil temp of 40 degrees before we do a run up. And again, the cylinder head temp seems to lag the oil temp on most of these engines. After starting, we want to see 40 PSI in 30 seconds. Otherwise, shut the thing down and investigate. We talked about a hot mag check once a day. We get good practice. And then as far as pulling the engine through, make sure the mags are off. Want to pull a cylinder, want to pull the thing through, make sure we don't have any abnormal resistance when you pull the thing through. These things can accumulate oil after they've sat for a while. And so when you're pulling the thing through, if you get strong resistance on one of the cylinders, really the only way to clear it is to take the spark plug out. Don't pull it backwards and try and put oil into the induction system. So it'll just come back out again and load up in the cylinder, and you could kink a rod. So that's obviously pretty serious stuff. So pull it through before every flight. You have compression, which is a normal feeling, and then you have more of a resistance where you're really having to fight it to move the blade. So when you experience that, pull all 4 or 5 of the bottom plugs, gently pull it through. You'll probably get oil coming out of one of the plug holes. So and put it back in. Torque the plug. 300 inch-pounds, and put the lead back on it, and away you go. Okay, back seat versus front seat functionality. We talked about the back seater is unable to put the gear down or up, so that's some. In this airplane, the back seater doesn't have access to a magneto switch. That's only in the front seat, and then intercom controls, radio, all that stuff is controlled by the front seat as well. So back seater is going to be often asking, "How's this? How's that?" And so in a training scenario, as we're doing things, front seat communicating to back seat is a good thing. It's appreciated.
Hey, Tom, I think on our airplane, the back seater can put the gear down, but he can't raise it.
Okay. Yeah. So depending on how depending how the down lock is set up in the front seat, that's going to be different airplanes. So I've had guys sometimes unlock the gear for me so I can put it up when we want to out of the back seat. So we'll play with that in the air and see how that looks. Okay, let's see. Couple cautions when you're doing the rides. Okay, so your PIC, you're flying rides, and you got a guy in the back. This very airplane had a ground loop up at test pilot school one time because in this particular case, the guy in the front boots jammed the rudder pedals. Got him stuck between the rudder pedals and the side panels. And so John Selk was driving, and the airplane got going sideways. So he said, "My airplane." So the guy in the front cleared his hands well, and he moved his boots off to the side, and the rudder grabbed one of his boots and basically jammed the rudder, and the steering, and the airplane went up on a wheel and turned and ground looped. So as you're doing PIC, you got a guy in the back. If you're letting the guy in the back fly or do whatever, make sure when you say "my airplane," you get feet and hands and arms off the controls. That was a lesson we learned the hard way. All right, other things to think about. So when you're doing your pre-flight, give the cowling some good attention. Make sure those 3 latches are on properly. Make sure the cowling is not too tight. Remember, the engine grows 1/8 of an inch, and so if somebody put the cowling on and they just herped it down, so it's just freaking on there, super super tight, you can actually start breaking those cowling lugs that hold the cowling on. You want it to be able to float just a little bit. Let's see. So what I do is I check the 3 latches. I grab around the both sides, make sure I can feel those little dowel pins that go up and nest the cowling sections together. I make sure I can kind of get a gauge on how those things are. Look at the gear rollers on the bottom of the gear. Check the springs on the gear locks. Check the latches. Look at the top of the lugs. We talked on the pre-flight about looking at the barrels and the heads and the nuts on the end of the shafts there. Check the propeller. Make sure the blades are nice and tight in there. You can grab the blade and give it a little bit of a tug and just kind of move it back and forth. Make sure the counterweight bolts are nice and tight. And now's the time to find all that stuff on the ground, believe me. Okay, and then also it's oil, air, cooled engine. Make sure you got plenty of oil when we're flying on a hot day. You want to have it up, up service well. Depending on the engine, you want to make sure we know what the hot oil shutdown was. I think that we put that in the book, don't we, then? Hot oil levels, like,
Yeah.
8.5 gallons or whatever. You don't want to overfill it either. So that's the other thing you want to be careful of. You can damage the oil tank if you overfill it. All right, let's see. Talk about the strut extension, tail sheet cover we talked about, generator failure. On an alternator, if the thing has gone offline, you want to pull the throttle back and then switch the alternator back on again. And that'll hopefully save you from killing your alternator. Let's see. If you're in air work and the thing spazzes out on you from going negative, pull the throttle back as the thing relights so it doesn't overspeed. That's a good thing to be thinking about. And then another point is when you're doing takeoffs and landings, if you're landing the airplane and it starts getting crossed up, throttle is your friend. Don't be afraid to add power and take it around. It's no big deal. Okay, let's talk about some emergencies, and we'll be pretty much done. All right, so there's two kinds of fires you can have on a startup. You can have a stack fire, or you can have an induction fire. On a stack fire, where you've got fire coming out the exhaust, keep it turning, try and get it to start. Hope you got a guy there with a fire bottle. Keep it cranking, try and get it to go. And if you still can't get it going after you run a hell of a bunch of cranks on it, and go ahead, mixture off, fuel off, mags off, go ahead and shut it down, and hopefully you don't have anything going on that's going to be injurious. But try and get it going if there's any way you can. On an induction fire, say the airplane got flooded, they actually can flood pretty easy, when they're cold. So if a guy has wobbled fuel pressure to it, primed it, you're trying to get it to go. If a guy has given it maybe some shots of with the throttle, if you give it more than one, you can, and the thing tries to light and backfires, you can get an induction fire going. And so it's going to burn down there on the carburetor, below the carburetor. So in that case, you want to fuel off, throttle off, secure the airplane, get out. Hopefully you got a guy with a fireball that can help. But in that situation, even if you were to get it to run with a fire in that area, you don't want to keep it running. If you want to check all the hoses and stuff in there, make sure you haven't done any damage. Because it's gotten 1400 degrees, whatever in there. You want to just make sure there's nothing wrong. Okay, engine fire in flight. Okay, so this one, if you've got a fire going in flight, you want to shut down the fuel, close the throttle, close the mixture, dive the airplane and try and put it out. Get the airplane up to 200 miles an hour and see if you can get the fire out. If it keeps burning and you can't get it out, you're gonna have to get out of the airplane. So in that case, just hope to hell you got a parachute and you can get out of it. That's a no-win situation there. Another thing that's come up in the past, and there's actually a service bulletin on this one, is if you're flying along and the fuel pressure goes to 0 and your engine's still running, don't change anything. Leave the throttle set where it is, leave the mixture where it is, keep the same speed on it, drive the airplane somewhere where you can get it on the ground. Most likely you've got a fuel leak in the accessories section. And if you change speed or you change power setting, you could affect the airflow in there that's happening, that's keeping it from combusting. So I would get somewhere as fast as I can with a big long runway, and then just shut everything down. Mixture off, fuel off, throttle off, keep your speed up, get the thing to the ground and land the airplane. There's something going on there that it can be really, really ugly. Okay, so engine failures, they're going to be the kinds that are instant. They'll be the kinds that you're going to get a nice warning about. During takeoff, if you get an engine failure on takeoff, during takeoff. Let me rephrase. During takeoff, but close the throttle. Get on the brakes. If you can't stop it before it goes off the right, but you're still on the ground, retract the gear. Mixture off, fuel off, and get out of the airplane. That's if you're on the ground. If you have an engine failure after you've taken off, obviously the first thing you do is you want to aggressively push the nose over. You want to maintain flying speed. You can change tanks really quickly to see if that might help. If you don't get a relight right away, again, small heading changes, gear up. If you can't get a stop, gear up. If you're going off airport, fuel off, put the flaps down to slow yourself down, but fly the airplane all the way to the crash. That's the absolute best thing to do. Okay, and a partial engine failure, when you're flying along, the engine just starts running shitty, running hot, maybe oil pressure is getting lost. try changing tanks, try wobbling some fuel pressure if you're not getting fuel pressure. Mixture rich, prop increase, mags both. If it's still running shitty and snotty, get somewhere where you can land the thing safely. Okay. All right, on a complete engine failure and you're up at altitude and the engine hasn't blown up, so you don't really know why it quit running, you go ahead and try and restart it. Okay, so idle cut off, throttle all the way back to nothing, and let it spin some 15, 20 seconds to clean out. Put the mixture back in, put the throttle about a quarter, prime it. If it doesn't start, prime it, hit the starter, try and get it going again. If none of that works, then you're going to have to secure the airplane and do a dead stick landing. Then you're back to another diagram where you're 100 miles an hour, gear up, flaps up, prop decrease, drive it somewhere where you can land the airplane, secure it in the air and land the airplane. If you're at an unimproved area, make sure you got the gear up. If you can get it down where you've got somewhere that's improved, try and land it with the wheels down. Okay, on takeoff, if the engine starts running a little rough, but it's still running strong, but it's running a little rough, try pulling the throttle back a couple inches. You might be getting some detonation for some reason. Would be something to try. Let's see. Let's talk about safety equipment for a minute. Really good to be, thinking about safety all the time. So it means a helmet, no headset, but a helmet, gloves, good footwear, parachute if you can get a hold of one, and a visor. You want to make sure if you get a bird strike or something, you got a visor down to protect your eyes. Make sure the shoulder harnesses are locked on takeoff and landing. And these airplanes are 80, 90 years old, so maybe keep a 3G limit. I know it says 5.67, but I don't know. Think about it. Another thing that's really good to have done, I don't know if this airplane has it or not, but there's a company that sells underwing wing attach guards. And Ben, do you know if those are on this airplane or not?
I don't think so. I've done the the fairings over there, and I've seen I haven't seen any on there.
Yeah.
So I'll just add that to my wish list.
Yeah, so these are carbide, look like short little skis, and
Okay.
they bolt on to 4 or 5 of the wing attach bolts underneath the wing attach angles. And if the airplane ever had to slide in, that will keep the airplane off the wing attach angles. And so then you're just talking about, hopefully the tail wheel will keep the airplane lifted somewhat too. So that'll go a long way toward really minimizing damage from a gear wheels up landing.
Does that require 337 or anything?
Nope. Bolts right on. Doesn't affect flight or anything at all. So, all right. So we got a question here that we can work on. If you want to do that independently, or I can help with it too. So
Okay.
be safe, don't do anything dumb. We don't want to hear. Watch this. Let's go fly, and then here's a picture Ben sent me showing those are the CF boys. The guy in the back's trying to make a Cosmo or something. Anyway, great movie if you haven't seen it. It's Mad Mad World. It's a super fun movie.
Hey, Tom, real quick, landing gear operation speed is 140,
Yeah, 145.
145.
Yeah, 145.
Okay. Hey, thanks, Tom.
I have 140 from when you said it earlier, Tom.
Yeah, kind of what happens here is I get goofed up a little bit. I use 140 in my airplane because I'm trying to take care of my gear doors. That's the main thing that gets impacted by a high gear speed is gear doors. I saw a guy put his gear down one time at about 175, and it's like he went by me like going like stink. I was doing like 150, and he put his gear down, and he came back, and one of his gear doors actually bent. It bent up like it bent 90 degrees. Crazy. So the gear itself doesn't care, but the gear doors would be tortured. And so I've rebushed mine like twice. I'm just trying to go a little bit more conservative. But the book says 145, and I use 140. So.
Okay.
I got a question on the V&E. You said the FA's got a limit of 226 on that. Does that apply to all T6s, or is that? I've run across that before, and I think ours is still redlined at 240.
That's a really good question. I don't know the answer to that. It's a good idea to check the STC and just see what it actually says.
All right.
I'd seen some of the documentation used to go as high as 248. And so some are placarded at 240 and some are 226.
Hey, Tom, I know it's getting late and thanks for all that talking, but I appreciate putting this together for us.
You bet, man. My pleasure.
Thank you.
So, hey, if you guys have things that need more clarification, let me know. I'm just trying to make this thing. I know it's long, but I'm trying to just make it as accurate. And so I'll check all the gear speed and the VNEs just to have the FAA most current that I can find.
Okay. So for everybody, I sent a test out to everybody, I think. Make sure you got one. There's 42 questions on it. It's open book. If anybody wants them, I have kind of a cheat sheet that I can send you to fill out the it's an open book test. Okay. So if anybody wants one, let me know and I'll send it something to you. When you complete the test, if you would just make a copy of it, or hopefully you would just scan it for me and send it to me, and I will make sure it gets in our records.
Yeah, Steve, would you go ahead and send me, because I'm kind of following along, but there's some questions that I
Sure.
did not answer based on the lecture. So if you don't mind, I'll send that out if I can just fill in the rest of the test.
Okay, yeah, and I know it's past your bedtime probably out there.
It's 10:30 out here. Yeah, but it's still about 85 degrees
Oh, nice.
with about 88% humidity. That's
Oh, yeah, not so nice.
That's so nice.
Thanks for staying up, Craig. Hey, Craig, send me a copy of any questions that you didn't feel were answered on there. I'll make sure I'm more clear next time.
Oh no, and that's just I was trying to follow them as we were going through the lecture. But there's something that I missed, probably just falling asleep or something like that. But yeah, Steve, if you'll send the answers, then
Yeah, and Tom, I'll send you the thing too, so you can look at it and correct the numbers also for me.
Sounds good.
Cool. Hey, thanks everybody.
Right.
Really appreciate
Thanks for your time, everybody.
thanks,
Last
guys.
question, any chance we can get a copy of the slides?
Have a good night. I can probably give them to you on a thumb drive. They're like 100 megabytes, so I can't email them.
Okay.
They might maybe on a Google Drive or something. I'll find out. I'll try and make it
Or like print it as a
find way to do it.
PDF is an easy way to drop the size, but thanks.
Okay.
Thanks, guys.
Thanks, Jonathan. Thanks, Craig.
Thank you.
Gary. See ya.
All right. And I'll make sure that everybody who attended gets updated on Rally Point.
Okay, yes, even if you'll send the answers, I'll get the test back to you.
Okay. Thanks everybody. Appreciate it.
Yeah.
Thanks.
Yeah, good night.